When we're going the opposite way of naming compounds, so we're given a name and now we have to draw them either as a displayed formula, a skeletal formula, or a structural formula. The first thing you want to do is you look at the name you're given and you're going to identify your functional group. So if I look at this first example, I have octane. So because it ends in A-N-E, I know that it's an alkane. Once I know the functional group, then I look at how many carbons it has. So this is oct, and oct means 8. So I know that this has 8 carbons that are joined together, and they're all alkanes, which means they're single bonded. So drawing the displayed formula, that means I have 8 carbons, and each one of them is surrounded by hydrogens. Okay, and then you fill in all the H's, making sure that every carbon has 4 bonds around it. So there is our displayed formula based on its name. But now I also need to be able to write that structurally. So if I look at this, remember structural formula is only having the carbons and the hydrogens and all the different individual atoms, but without showing the bonds. So this first one is a carbon, and on that carbon is 3 hydrogens. So I've got CH3. Then attached to that is a CH2. But I have 1, 2, 3, 4, 5, 6 of them. So I can put that whole thing in brackets and say that there is 6 of the same thing over again. And then our last one is a C with 3 H's attached again. And then if I want to draw that as a skeletal formula, all I'm going to show is the points for the carbons, but no letters, no hydrogens, no carbons, or anything. So each point representing a carbon, so I have 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So that's its skeletal formula. And if I look at the next example, I now have side chains. So I'm still going to do exactly the same thing as I did before. You look at your name and you identify the functional group. So this is ane, which means it's alkane again. Then I look at how many carbons I have. So pent means 5. So I know that I have 5 carbons in a row that are all single bonded. So I can draw those out. Okay? And now I look at the side chain that I've got. So meth means 1 carbon, and that side chain with 1 carbon is on carbon 2. So I can go 1, 2, so on this second carbon, there was the side chain of just 1 single carbon. And then I fill in all the hydrogens to make sure that carbon has its 4 bonds each. Okay, so you're going to then write in all the H's all the way around. And then we need to draw that structurally. So again, starting with my first carbon, I have C, and there's 3 H's on it. Then the next one, I've got a carbon. On this carbon, there is 1 H and the side chain. So in brackets, I say CH3 because this bracket means that that whole thing is attached to the carbon before it. Then I can move on to the next one, and I've got CH2, CH2. Those can be combined and put into brackets, and you say CH2 with brackets 2, or they can be separate. And then CH3. And if I draw that skeletally, I'm going to draw each of my points for my carbons again. So I've got 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 points. And then on carbon 2 is the side chain. So on carbon 1, 2, side chain going up. We always draw our chains in the direction of the points. So this one is going up, so I draw it up. If this one would be going down, then I draw it down, just so that it flows. Okay, and if we look at the next example, same steps. Identify the functional group, alkane. Number of carbons, 4, so it's bute. Okay, and then I've got some side chains. So because I know my longest carbon chain, I can just draw them straight in a row first. And then I look at the side chains. So meth, meaning 1 carbon, but di, so I have 2 of the 1 carbon chains. And they're on carbon 2 and carbon 3. So on carbon 2, I can draw my 1 side chain, and on carbon 3, I can draw the next side chain. And then you fill in all the hydrogens. Okay, and then to draw that as a structural formula, starting with CH3, then C with 1H, and on that carbon there's then the side chain. So brackets CH3, because that bracket's showing it's to that one before then. Then I've got another carbon with a hydrogen attached, brackets for the CH3 on that one, and then my last CH3. And then skeletal formula, 1, 2, 3, 4 carbons, and on carbon 2 is a side chain, and on carbon 3 is a side chain. So like I said before, this one goes up and this one goes down. So then if we look at our next example, now I've got a different functional group. So if I look at this one, ends in ene, which means I have an alkene. Then I still look, I have 4 carbons because it's bute, but because it's an alkene, it's been numbered. So the double bond is on carbon 1, meaning it's between carbon 1 and 2, because you always number the carbon that's the smallest before the double bond. So I've got 4 carbons, and on carbon 1 there was the double bond between carbon 1 and carbon 2. Then I look at the side chain, so I've got meth again, meaning 1 carbon, and it's on carbon 2. So on carbon 2, I've got the side chain. So now we need to then fill in all the H's. So this carbon already has 2, so it's only missing 2 H's. This carbon already has all 4 bonds, so it's got nothing else there. This carbon has its 3 H's. Then that carbon has its 2 bonds, so it's missing 2, and it's missing 3. So now, to draw that structurally, when we write our structural formula, we always do indicate a double bond. So I start with C, and I fill in the double bond. Whenever it's at the end, the most correct way to do it is to put the H's on the first side of the carbon, so beforehand, because it means on this carbon, there's the 2 H's and the double bond. And then I've got a carbon, again, for this one, but there's nothing else attached to that except the side chain. So we put the side chain in brackets, and then we move to our next one, which is CH2, and then our last one of CH3. Okay, and then if I want to draw that skeletally, I show the double bond as well, but double bonds are always drawn straight, not at angles like that, just because of the way the molecule is built. Okay, so I have straight lines, and then that's carbon 1, carbon 2, 3, and 4. And on carbon 2, there is this side chain. Looking at a few more examples, if I have 1,3-betadiene, so identifying the functional group is an ene. Before that ene, there is a di, and we know that di means 2. So this means there is 2 double bonds on a 4-carbon chain, and those double bonds are on carbon 1 and carbon 3. So I'm going to draw my 4 carbons first. Then I'm going to fill in my functional groups of my alkenes, and that's on carbon 1. So from there, between carbon 1 and 2, and then on carbon 3, so between carbon 3 and 4. And there's no other side chains on there, so now I can fill in the hydrogens. So there's already 2 bonds on this carbon, so I can need 2 H's. On this, there is 3 bonds, so I just need 1 H. Still 3 bonds here, so I just need 1. And then there's 2 bonds already, so I'm missing 2. So there's our displayed formula. To draw that as a structural, starting with my carbon, I'm showing the double bonds just like earlier, and there's 2 H's on this one, so I can write them backwards. Then on this carbon on that side, there's 1 H. Then there's another carbon with an H that has a double bond to the last CH2. And then to draw that as a skeletal formula, I've got double bond between carbon 1 and carbon 2. Then I go to carbon 3, and on carbon 3 to 4, there's another double bond. Okay, if we look at our next example, functional group, first I have ONE, which means ketone. Then I look at how many carbons, so pent means 5, and because it's a ketone, it could be on any carbon, and I've indicated it's now on carbon 2. So I start by drawing my carbon chain. So I have 5, and then the ketone is a double bonded oxygen, which is now on carbon 2. So on carbon 2, there is double bond O on my 5 carbons. And then I can fill in all the hydrogens. So this already has 4 bonds, so there's nothing there. And then on the next one, we're missing 2 and 2, and then 3. So there's my displayed for my ketone. Now to write that as a structural formula, I've got C with 3 H's. Just like there, the most correct way to do it is to put the H's on this side, but you won't be penalized if you put them on the other side either. So there's C with 3 H's, then I've got a C, which is attached to an O, which is then attached to another C, which has 2 H's, C with 2 H's, and C with 3 H's. So there is our structural formula. And if we're going to draw that as skeletal, we're going to indicate the double bonded O on it. So firstly, we're going to draw our 5 carbon chain. So I've got 1, 2, 3, 4, 5 carbons, and on carbon 2, there was the double bonded O, which we draw upwards in the direction of the point. Okay, and if we look at another example, so now I have ethyl propanoate. So from that name, I can identify that this is an ester. So remember, the first part of the ester, the "-ile", came from the alcohol side, and the OH part comes from the carboxylic acid. So F is 2 carbons, so I have 2 carbons that came from the alcohol, which always gives the O in the middle, and then I have propanoate, so 3 carbons coming from the carboxylic acid. So on the other side of the oxygen is my 3 carbons from the carboxylic acid, which had the double bonded oxygen. So I know that the double bonded O goes there on that carbon with the O in the middle between the ones that came from the alcohols and the ones that came from the carboxylic acids. And then I can fill in the hydrogens. Okay, so there is then our displayed formula for our ester. So now if I want to write that structurally, I've got starting with a carbon, and that carbon has 3 H's on it. Then my next carbon has 2 H's on it, which is then attached to an O, and then I've got another O for the next carbon. So when we write structurally for an ester, we always say O in the middle, and that's how we know that we're referring to an ester. And then I've got a CH2 and then a CH3. And then if I'm going to draw that skeletally, I'm starting with my first carbon. So I've got carbon 1, carbon 2, and then from carbon 2 there's an O in the middle to the next carbon, which then had carbon 1, 2, and 3. And on that carbon there was the O. So there's my ester functional group in the middle of my skeletal formula. Okay, now if I look at one last example, I have 2-methyl-2-propanol. So my functional group is the ol, so that's the alcohol. And I know that those have to be numbered, so I'm told that that's on carbon 2. And my longest chain is prop, so that means 3 carbons. So I draw a 3-carbon chain, and on carbon 2, there was the OH. And then I have a side chain. So meth, meaning 1 carbon, and that was on carbon 2. So on carbon 2, I also have a C with the H's around it. So now I can fill in all my H's that I'm missing. And there I have my displayed formula. So now to write that as a structural formula, I've got C with 3 H's on it, with another C, and on that C there is an OH, which I can put in brackets, and a CH3 side chain, which I also put in brackets. So it means that these 2 brackets are both attached to this carbon. And then my last carbon is CH3. And drawing that as a skeletal formula, I've got 3 carbons, so 1, 2, 3. And on that second carbon is the OH and a side chain. So we draw both of them going up, just like that. Okay.